Let's go through Liquid 1813. Sentence similarity is 3. For this question, it gives us string sentence 1 and sentence 2. And the two sentences S1 and sentence S2 are considered similar if it is possible to insert an arbitrary sentence, possibly empty, inside one of these sentences. Such that the two sentences become equal. Note that the insert sentence must be separate from existing word by space. So you see that for sentence, there are words separated by space. There is no space before those kind of words. So we don't need to do something like a trim or those kind of things. So let's try to tell whether sentence 1 and sentence are similar or not. So what we're thinking about is that the first is that we want to see their length, right? So let's make sentence 1 always be a longer one, and sentence 2 be a short one. So what we do is that if sentence 1 dot length is smaller than sentence 2 dot length, right? We just do recursive code, right? As equal and sentence 2 and sentence 1, right? And then what we do is that we have a pointer pointing to at the beginning of sentence 2, which is I, and another pointer is at the end of sentence 2, right? So let's look at this kind of I word by word, trying to see whether they are equal or not, right? So if not equal, for example, someone stop here, right? Then our I will break. So in the end, this I will stop in a place which is the word does not equal. Or I just at the end, right, means of course if it's n, then that is residential. That means it's not break. And in the meanwhile, we have another pointer pointing from the end of the sentence to right, just compare word by word. If the same thing, if not equal, right, then we break J, right? So if these two sentences are similar, in the end, what we need to do, we need I should greater than J, right? That means we are able to cover this kind of sentence. Otherwise, if I equals J, right? Let's say that means they stop at the same point. Means this kind of word is not being covered. So just return I greater than J. Then that will be our result, right? So let's write code for this. As we talk about, we need to separate this kind of array string into arrays. So will be sentence 1 dot split. So we need to split by space, right? We can use this one, or we can use this one. Split. So string array 2 equals sentence 2 dot split. So let's say if array 1 dot length is smaller than, let's always as array 1 has a longer one, right? Array 2 dot length. Then we just we can call this one, right? And or we can just have a string temp, right? Temp equals array 1, and I have array 1 equals array 2, and array 2 equals 10, right? And let's have set this length out. M equals array 1 dot length, and n equals array 2 dot length. And let's set two variables in I equals to 0, right? And j equals I minus 1. So what we do is that for I smaller than n, I plus plus. So now m is longer than n, right? We can also have a p equals m minus n. Okay. So what we do is that if array 1 dot I doesn't equals to array 2 dot I, just a break. Right? And in the meanwhile, we just from the end, right? If j greater or equal to 0, j minus minus. So if um, array j, we should pass d, right? That equals to array 2j. We also break. In the end, we just return I greater than j, right? And the time complexity will be O n, right? And the Python code will be very similar. So what we do is that mm, just the split function is array 1 equals sentence 1 dot split. Array 2 equals sentence2 dot split. So what we do is that if length array 1 is smaller than length array 2, we just swap. So array 1, array 2, plus array 2, array 1. Then let's say int m and I j d equals length array 1, length array 2, and I equals 0 and t equals m minus 1 equals m minus n. So we'll say while I is smaller than n, and array I 1 I equals array 2 I. So we'll keep increasing I. And we'll say while j is greater than 0, and array 1 d plus j equals array 2j, keeping decrease 1, right? In the end, we just return I greater than j, right? Here, because in Python, this is when this defined, right? So we need define this outside, right? J equals n minus one, and D equals n minus n, right? One J plus zero.